So now we're going to be moving on to the first of two types of collisions involving more than one object. And we're going to be talking about direct collisions. So direct collisions occur when two coplanar objects, so objects along an axis, bump into each other, kind of like two cars on a road if one is going the wrong way down the motorway. So we have to extend our knowledge of Newton's law of restitution before we actually go into direct collisions. We also use this simultaneously with the conservation of linear momentum in order to get velocities v1 and v2. After that, we can solve for the velocity of either sphere. So what do I mean by furthering our knowledge of Newton's law of restitution? Well, before we've seen that for single body collisions, the coefficient of restitution is minus the final velocity over initial velocity. But the u and v parts represent what's known as relative speed. So this is commonly done in some physics courses. I personally didn't cover it. So the speed of one sphere relative to another is simply the difference between their velocities. So the initial velocity, or the initial relative velocity, is the initial velocity of the first minus the initial velocity of the second. And the same thing can apply for the relative final velocity. So what we get is E is minus V1 minus V2 over U1 minus U2. That's not a 2 at all. So when we multiply across, we get E times U1 minus U2 is minus V times V1 minus V2. So if we flip the signs, we get this equation, which is actually the most common form of Newton's law of restitution. We're going to be using this along with the conservation of momentum. As you can see, we have a V1 minus V2 and a V1 plus V2. So we will be able to do simultaneous equations and find those respective velocities.